here and Wi-Fi on பண்ணிட்டேன். Those are online, are you able to hear it?
Yes, sir.
Okay. Shall we get started? So just to recollect the concepts, you remember all these concepts that we discussed? Fleming's left-hand rule, then motion of a charged particle in uniform magnetic field. So for that, we saw the first case when the value of theta is equal to 0, it travels in a straight line. When the value of theta is equal to 90 degrees, it travels in a circular path. And what is the radius of that circular path? It is mv divided by qb or p divided by qb, or it is also written as root of 2m into k divided by qb. Right, time period of one revolution. So time period is equal to one revolution divided by speed. So that is going to be equal to 2 pi r divided by v, or 2 pi r, if you substitute mv by qb, it will come out as 2 pi m divided by qb. Right. So one thing we saw was time period is independent of speed with which you project the particle. Similarly, what about the frequency? Frequency is qb divided by 2 pi m. Right now. So the next concept that we are going to see is this one. So next concept that we are going to see is motion of a charged particle in uniform magnetic field. But this time, right, this time it is projected with an initial velocity that makes an arbitrary angle with the field direction. In the sense, theta is not equal to 0 degree or 180 or 90 degree. It is anything other than these values. If it is projected with anything other than these values, then how is the particle going to travel is what we are going to see, right? So that is why in this case, if you see, the magnetic field is taken along the horizontal, and let me call that value to be d. Now, if I take this particle and let's say we project it with a speed v, making an angle theta with respect to the horizontal, then this v itself can be resolved into two components. What are the two components? V cos theta, and it is going to be V sin theta. Now what will happen is this V cos theta will put the charged particle in one kind of a motion, and V sin theta will put it in a other kind of motion. Let's see what it is. Okay. So from the first concept, we know that when the angle is 0 degree or 180 degree, so the particle travels in a straight line path, right? So what is happening here is V cos theta, since it is parallel to B, what is happening? V cos theta is parallel to B, then what will be the value of theta? Theta is equal to 0 degree. Hence, the particle continues to move in a straight line. right? In a similar way, if you look at this V sine theta, now what is happening to V sine theta? V sine theta is going to be perpendicular to B vector. So the value of theta is going to be equal to 90. So when it is 90, it is going to be a circular path. So what is happening here is, unlike the previous two cases where there were only one of these velocities that were existing, right? In this case, both the velocities are simultaneously existing, as a result of which the motion of the particle will neither be a complete, the particle will neither be able to move along a straight line or completely in a circular path. So what is going to happen is, it is going to have a combination of these two motions, which will be in such a way, if you try to visualize it, due to V cos theta, the particle will travel like this. And due to V sin theta, the particle will travel in a circular path. So when I see from here, it is going to go travel in a curved path. So it is going to be into the plane and coming out of the plane. At the top, it will go into the plane. At the bottom, it will come out of the plane. Let's try to test that and see. So what is the direction in which the charged particle is going to experience force according to Fleming's left-hand rule? If I take the charged particle Q to be positive, right? Field is in this direction, right? Current is in this direction, because the direction of current is taken to be the direction of the charged particle itself. Current is upwards. So when I extend the thumb, it is going to be into the plane. So the particle is going to go into the plane at the top, come from the bottom at the, come out of the plane at the bottom. So when I see from this side, it is going to have an anti-clockwise motion, right? It is going to have an anti-clockwise motion. So anti-clockwise motion, circular path plus translational motion. So circular motion plus translational motion will put the particle into this kind of a path, which is called as helical path. So it is a combined circular and a translational motion. Are you able to understand? So it is going to be helical motion, right? Now the question is, though it is going to be helical, still it is going to take a circular part in some of the places, right? It is taking a circular shape. So that circular shape has a radius associated with it. So what is going to be the radius of the helical path here? So what is going to be the radius of the helical path here? R will be equal to M into V perpendicular divided by Q into B. Because what is the radius of the circular path? R is equal to MV divided by QB. So here, which velocity is responsible for the circular path? It is V sin theta, which is going to be the perpendicular velocity. That is why I wrote M into V perpendicular divided by QB, or this can also be written as MV sin theta divided by QB. So it is going to be MV sin theta divided by QB. Are you able to understand? So this is going to be the radius of the circular path. I mean the helical path, right? Now, what is going to be the time period of this particle? So time period is going to be still calculated as 2 pi m divided by QB, because time period is independent of velocity. So it is still going to be 2 pi m divided by QB. So I hope these 2 points are registered, right? Now an important question that we need to answer is, see, if it is circular path, if it starts here, after completing one revolution, it is going to come back to the same point. But what is happening here? By the time it completes one revolution, it is pushed to certain distance horizontally due to V cos theta. So what is happening? The particle is starting here, but by the time it completes one revolution, it is not coming back to the same point. Rather, it is pushed by a certain distance along the horizontal. So what is this distance called as? So the distance traveled by the particle, in the horizontal distance traveled by the particle in how much time? In one complete revolution is what is called as pitch. So for a helical path, there is something called as pitch. So what is pitch? It is the horizontal distance traveled by the particle in one complete revolution, right? So when I say pitch is equal to horizontal distance traveled in one complete revolution, then how much is the value going to be equal to? Which will be equal to, which is distance? Which is distance. So what is the distance formula? Distance is equal to speed into time. So which is the speed? Remember, v is the velocity, but when you divide it along certain direction, the components become the speed. So v cos theta is the horizontal speed and v sin theta is going to be the magnitude of the vertical speed, right? Generally, we don't use vertical speed. It is the speed along the vertical direction. That's okay. So it is a magnitude of velocity. Now, which speed is responsible for which to come into picture? It is v cos theta. So it is v cos theta. And how much time is it taking to travel from one point to another? Traveled in one complete revolution. So for one complete revolution, what is the time it takes? It takes one time period. So this will be equal to v cos theta multiplied with the time period is going to be 2 pi m divided by qb. So the answer will be 2 pi mv cos theta, the whole divided by qb. So this is going to be the formula for which. Is the point clear? So these are all the important terms that you need to keep in your mind. So just to summarize, when theta is equal to 0 or 180, the path is going to be straight line. When theta is equal to 90, it is going to be circular. Since here it is neither 0 or 180 or 90, right? It is going to have a combined circular and a translational motion, which will take the path called as helical path. For the helical path, what is going to be the radius? It will be mass into v perpendicular, the perpendicular component of velocity divided by qb, which is mv sin theta by qb. What is the time period? The same as that of circular path, which is 2 pi m divided by qb. And what about the pitch? The pitch is going to be equal to speed into time along the horizontal direction. So speed is going to be v cos theta, time is going to be one time period. On substituting all the values, we get the answer as 2 pi mv cos theta, the whole divided by qb, right? So this is all about the motion of a particle when it is projected at an arbitrary. Okay, this is also very, very important. Make a note of it.
Sir, we can't hear you.
Yeah. So what is going to be the direction of motion of electron? It is going to be opposite. So it is going to be drift velocity in the opposite direction. Is that point clear? Right. Now, this is going to be positive terminal. This is going to be negative terminal. And let's say that the length of the conductor is going to be L. Can I do that? Right. Now, tell me what is going to be the force that is experienced by that electron. So what is the force experienced by the electron? So what is it? No, I'm not asking about the direction. I'm asking what is the value of it. F is equal to E into Vd vector cross B vector. What is this basically? This is the Lorentz force, right? So if I write this as F vector, can I write this as minus E into Vd vector cross B vector, because electron has a negative charge, right? Now, since I'm talking about the current carrying conductor, my job is to relate the charge of an electron to the current that is flowing through the conductor, right? So observe what I'm going to do is, if this is going to be the force experienced by one electron, right? What is going to be the force experienced? What is going to be the force experienced by n electrons? So what is going to be the force experienced by n electrons? F vector will be equal to minus Ne into Vd vector cross B vector. Can I write it like this? Now tell me one thing. F vector is equal to minus Ne into, how can I write Vd vector as? So we know that drift velocity is equal to the distance traveled by time. So when I write this as Vd vector, is this not going to be negative of L vector divided by T? Is it not going to be negative of L vector by T? Why? Because L vector takes the direction of current. But what is Vd vector taking? Vd vector is taking the direction opposite to current. So Vd vector will be equal to minus of L vector divided by T. So if I write that here, minus L vector divided by T, right, cross B vector, if I write it in this way, now what will happen here is minus of minus will become plus. So this will be equal to n into E divided by T into L vector cross B vector. Are you all convinced with this fact? Right. So what is n into E according to quantization of charge? It is the total charge. Q. What is Q divided by T? It is going to be current. So can I write this as I into L vector cross B vector? So what is happening here is, when you talk about a charged particle, the charged particle experiences a force of E into B vector cross B vector. Whereas when you talk about a current carrying conductor of length L, then the force experienced by the current carrying conductor is going to be I into L vector cross B vector. So this is going to be the magnetic force in terms of which quantity? vector quantity. Now, if I take the same thing and write it as an expansion of this, then it will be BIL sine theta times n cap. So what is B? Magnetic field. I is the current. L is the length of the conductor. Sine theta. What is sine theta? Theta is the angle between L vector, that is the direction of current, and the magnetic field itself. So theta is the angle between the direction of current and the magnetic. Is the point clear? So this is very important to be noted. So it is going to be BIL sine theta times n cap. If you write it completely in scalar quantity, F is going to be equal to BIL sine theta. Right? So this is all about the force that is experienced by a current carrying conductor that is placed in a magnetic field. Okay. So write down this derivation. Done with this? Okay. See, now the question is with this n cap, right? So what does that n cap mean? N cap is a unit vector which is perpendicular to both the vectors for which you're doing the cross product, L vector cross B vector. Now, can we apply the Fleming's left-hand rule here? Yes, you can very well do that. So how is it going to be? Observe. Forefinger is in the direction of field, central finger in the direction of current. So how are you going to put it? Like this, right? This should be in this way and this should be adjusted But here we cannot do it because they are not mutually perpendicular. So try to understand. So here it is B vector. If suppose the current was upward, then the force would have been into the plane. But still here what you can do is you can calculate it with the help of vector quantities. Right? How you can do is, if you observe I vector is entering into the first quadrant. So when it is entering into the first quadrant, what are the two variables it is going to have? It is going to have I cap and J cap. So it is going to be having I cap cross I cap plus J cap, right? So this is L vector cross. What is B vector here? B vector is along X direction. So what is I cross I? This you should know by now. I cross I is how much? 0. Cross product between same vectors is 0 because angle between them is 0. No. So what is J cross I? J cross I will be minus K. See, if at all you don't remember, draw the circle I, J, K, where I, J, K are taken in the anti-clockwise direction. I cross J is going to be K, J cross K is going to be I, K cross I is going to be J. Similarly, anything in the clockwise direction is going to be negative. Okay, so make a note of this. So what is this direction of n cap? It is unit vector perpendicular to both L vector and B vector. Shall I proceed? So the next concept that we'll see is force between two parallel current carrying conductors. This is also a very important concept. Okay. So what is the force between two parallel current carrying conductors? So if you observe, if there is one conductor like this and another like this, which are parallel to each other, right? Let's say that the current here is I1 and the current here is I2. And let the distance of separation between them be D. Right? The distance of separation between them is D. Now we need to calculate what is the force experienced by one, force exerted by one on the other. Okay. Let's see how to calculate it. Now listen to this carefully. In the previous case, we calculated force experienced due to a current carrying conductor when it is placed in external magnetic field. Here, there is no magnetic field. So what is happening here? Both are current carrying conductors, right? So due to one conductor, we need to calculate what is the field generated due to at the second conductor and vice versa. So what I'm going to do is, I'm going to calculate the magnetic field due to the first conductor. So what is the magnetic field due to the first conductor near the second conductor? If I take this as 1 and this as 2, so what is the magnetic field due to the first conductor at the second conductor? It is going to be mu naught I1 divided by 2 pi into D. This is right. So here when I say two parallel current carrying conductors, they are considered to be long also, compared to the distance of separation between them, right? So mu naught I1 divided by 2 pi D is going to be the magnitude. Now tell me what is going to be the direction of this B1 vector. What is the direction of this B1 vector? Apply the right hand thumb rule and tell me. It is into the plane, right? It is into the plane, right? Now, when there is a magnetic field that is into the plane, if there is a current carrying conductor I2 that is placed in this magnetic field, what will happen? Just now we saw the concept. If a current carrying conductor is placed in external magnetic field, what will happen to the conductor? It will experience force. And what is the force experienced by it given as? F is equal to BIL sine theta. This is in terms of scalar quantity, right? Now, B1 vector is into the plane. I2 is flowing through a conductor which is long enough. So what I'll do is I will take a portion L here. So I'll take a portion L here and we'll calculate what is the force experienced by this portion L which is present on the second conductor. So what is going to be the value of force? F will be equal to BIL sine theta. No. So I'll write the same formula here. BIL sine theta. But what is the value of B here? This is the magnetic field produced due to the first conductor. Current is due to the second conductor. Length is a portion of the second conductor, right? And theta is the angle between current carrying conductor and the magnetic field. So current is flowing like this. Magnetic field is into the plane. If you turn and see how much is going to be the angle between, it is going to be 90, right? So what is the value of B1? It is mu naught I1 divided by 2 pi d into what is the value of I2? I2 is I2 only. Into what is the value of L2? L2 is going to be capital L, right? So it is going to be capital L into sine of how much value? 90, right? So it is going to be sine of 90 and this is going to be the value of force in terms of magnitude. Now tell me, if I put a bar on top of this, that is if it becomes a vector quantity, what is the direction in which the force is experienced by? Direction of field, central finger adjusted along the direction of current and extend the thumb. So thumb is pointing towards the left. So there is a force that is experienced in the leftward direction, which is given by the value F. This value is there, no F, that has a name called as F21. Means force experienced by the second conductor due to the magnetic field produced from the first conductor. So the suffix you are going to write is, sorry, the subscript that you are going to write is F21, right? So what is the direction of it? It is leftward. Makes sense, right? So how much is the answer going to be? Mu naught I1 I2 divided by 2 pi d into sine 90, and what is going to be the value here? Capital L is going to be equal to F21 vector, which implies F21 divided by L is going to be, or F21 vector divided by L is going to be, okay, I'll do one thing, I'll write only the magnitude so that since the direction is already known to us, we'll write only the magnitude so that we'll understand how this formula works. So F21 divided by L is going to be equal to mu naught I1 I2 the whole divided by 2 pi d. The meaning of this is, though the name of the topic is force between two parallel current carrying conductors, here we are not able to directly calculate the force. Rather, we are only able to calculate the force per unit length. So this formula of mu naught I1 I2 divided by 2 pi d is not going to give you the force directly. It will only give you the force per unit length. If at all you want to calculate the exact force, then what should they give you in the problem? They should give you the length of the conductor. You apply this formula, take the length to the other side, multiply, that will give you the answer for force. So here, what is the answer for it? It is the force experienced by the second conductor due to the magnetic field produced by the first conductor. Okay. So just make a note of it. What time are you sleeping, everyone at home? And face wash. What time are you people sleeping? Are sleeping or not in the night? When hours? Tired hours? Yeah. Huh? ஓடியா என்ன பண்ண 400 மீட்டர் ஓகே ஸ்போர்ட்ஸ் டே வாங்க ஸ்கூல் இல்ல ஸ்போர்ட்ஸ் டே போயிட்டு வந்தீங்களா இல்ல செலெக்ஷன் ஓகே எப்போ அது ஆகஸ்ட் you people didn't go why Saturday also ஓ நீங்க இன்னைக்கு போக தேவையில்லை நான் வரல let me know if you're done with this you're done with this okay I'll give you 2 minutes time you exactly do the reverse and tell me what is f1 follow the same steps only difference will be instead of b1 vector you'll find b2 vector instead of f21 you will find f12 so everything else is going to be the same find out and tell me what is the value of f12 divided by l Magnitude. Direction. Yes. Yeah. So now we'll try to do exactly the reverse. That is, we had the conductors like this. This is I1, this is I2. The distance of separation between them is D, right? The distance of separation between them is D. If you take this as the first conductor, this as the second conductor, what is the magnetic field due to the second conductor near 1? So that is going to be equal to mu naught I2 divided by 2 pi into D. It is how much? Mu naught I2 divided by 2 pi into D. What is going to be the direction of it? It will be out of the plane. Because when you apply right hand thumb rule, the current is upward. When you curl the fingers, it is going to be out of the plane. Right? So when it is out of the plane, we'll put a dot and a circle around it. Right? Clear? You find on one of the sides, I2 for the right hand side is it is into the plane. On the left hand side, it should be out of the plane. If you find one of the directions, it's enough no for magnetic field. I repeat, I2, due to I2, the current on the right hand side is, sorry, the magnetic field on the right hand side is into the plane. So obviously on the other side it will be out of the plane. That's it. Okay. So what is going to be the force here? Force is again going to be equal to BIL sin theta, but this time V is going to be B2, I is going to be I1, and L is going to be L1. So if you take this length of the conductor as L, right? So it is going to be B2 is how much? It is mu naught I2 divided by 2 pi D into what is the value of I1? I1 is I1 only. Length is going to be capital L into sine of how much is the angle between them? I1 is upward, magnetic field is towards you. So it is again going to be 90 degree. So what is the answer here? It is going to be mu naught I1 I2 divided by 2 pi D into capital L, which is F12. This is going to be F12. That implies F12 divided by L is going to be equal to mu naught I1 I2 the whole divided by 2 pi into D. Is that point here? Now the question is, what is the direction in which the force is experienced? So the field is in this direction towards you. Current is flowing upwards. So extend the thumb. So it is going to be in this direction. So I repeat it. Field this side towards you. Central finger current upwards. Extend the thumb. It is going to be in this direction. Right hand, left hand. So field, current, and thumb. So this is going to be the value of F12. So what is happening here? F21 is like this, right? So F21 is to the left, F12 is going to be to the right. In this case, there is an important point which I want you to make a note of. Right? There is an important point you need to make a note of. Thing is, when currents are flowing in the same direction, right? So here, what I'm saying is, currents, if they are flowing in the same direction, right? If the currents are flowing in the same direction, then they tend to attract each other. Similarly, if the currents are flowing in the opposite direction, right? If the currents were flowing in the opposite direction, then they would have repelled each other. You can check that and see. Okay, because the direction of magnetic field will change and the direction of current will also change in such a way that in that case, F21 will be to the right and F12 will be to the left. In the sense, they will repel each other, right? So this is not a concept which is, there's something similar to, or I can say the opposite to one that happens in the case of like charges and unlike charges. See, for example, if you have like charges, what will happen? There's one common mistake people do. That is why I'm stressing on this point. If I give you two like charges, what is the kind of force experienced by them? It is repulsive force, no? So when I say like charges here, what they do is the comparison is currents are flowing in same direction. So they will assume that they will tend to repel each other, but they will not repel each other. They will only tend to attract each other. It is exactly the reverse scenario. Are you able to understand what I'm trying to say? Right? You need to be very careful with this. So because questions are based on these factors also, these facts. If suppose they give a question saying that there are two current carrying conductors which are parallel to each other, what should be the directions of current in them so that they attract each other? So it should be seen. Okay. So that is how they'll frame the questions. So I hope it is clear, no? Right? So are you clear with the magnitude part? So magnitude part is going to be the same in both the scenarios because you took the same length of the conductor on each. That is why it comes out to be the same value. Right? Apart from that, the directions are going to change. Yeah. So you can make a note of. Opposite, no? One is upward, one is downward. If I1 is upward, I2 is downward, then they'll repel each other. See, next there are few more topics that are left out. Now we saw what is the force experienced by a current carrying conductor. Now, if it becomes a current carrying loop, right, there is a small difference in the word. If they use the word current carrying conductor in magnetic field, it will experience force. Current carrying loop placed in magnetic field will experience torque. So what we need to see is what is the torque experienced by the current carrying loop. Secondly, an application of that, which is a moving coil galvanometer, the one which you're using in your lab. I'm assuming that everybody has seen a moving coil galvanometer. You have done meter bridge experiment? You didn't go to lab at all? என்ன பண்ணீங்க அந்த ட்ரீயை ஃபோக்கஸ் பண்ணாது தானே? சரி, ஓகே. You know why you're doing that? எதுக்கு தூரமா இருக்கிறத ஃபோக்கஸ் பண்ண? எது ஃபோக்கல்? எப்படி தெரியும் ஃபோக்கல் என்றது? What is focal length basically? தியரிக்கும் படிக்கிறதுக்கும் பண்றதுக்கும் சம்பந்தமே இல்லை. எங்க ஏறும்? Basically focus என்ன point? What is focus? மறந்துருச்சு. 10th standardல படிச்சோம் சார், மறந்துருச்சு. Need not converge, they can diverge also. But where should those rays come from? So that's why you're actually finding it. So what you're finding is approximate focal length. கடையில வாங்கும்போது அது மேல focal length இருக்கும். புரியுதா? ஏதோ ஒன்று பண்ணுங்க. So you have not seen galvanometer at all. Okay, don't worry, I'll show it. I thought you people did meter, but that's fine. I'll show you. Okay. So what I'm trying to say is, and there is a concept called as conversion of galvanometer to ammeter. So record anything. If you put the record, you remember writing the galvanometer experiment. Half deflection method. Half deflection method or experiment. Okay. Other there will be some terms. The terms are going to pass along so that when teaching will be able to relate it. But in the time of when it comes to practical, the real context. So at least go through the terms. I don't want you to read completely. Go through the terms and I'll explain it to you. We'll understand how to convert a galvanometer to an ammeter. After that, there is ampere circuit. Maximum 2 more classes. Next week, what we'll do is do some problems. Right? Is there clear? You write down this. இதுதான் பண்ணிருக்கீங்க. எது? So then you know what is a battery eliminator. அதை பார்த்திருக்கீங்க. அந்த knob ஒன்னு இருக்கும் சுத்திட்டு இருக்கும். அதை பார்த்திருக்கீங்கல்ல.